So let's take a look at another equation that is quadratic in nature. It may be hard to see that it's quadratic in nature, but we see that we do have a constant here. Notice how these guys are pretty much, they're the same, right? X plus 7, but their powers are a little bit different. So what we're going to do is we're going to do something called a U substitution. And what that is that we're going to take this guy right here. This is the middle guy. He is the complicated part. I'm not taking the 4, I'm just taking the variable piece. And I'm going to let the letter U represent the complicated guy of x plus 7 to the 1/3 power. Now if you remember what we said just a moment ago, U is going to be this, and then U squared would be the same thing with double the power. So if this guy's power is 1/3 and you double that, you would have the 2/3 power, which matches up with what you see right here. So typically the guy that's here in the middle is going to be your U, and again, just the variable part, don't include the 4. And notice that if you double the 1/3, you get the 2/3. So that makes this guy your U squared. So what we do here is we make this U substitution, which tends to clean up the problem so that we can then do quadratic methods on this, and it becomes a fairly simple problem. So how would you rewrite x plus 7 to the 2/3? Based on our substitutions, you're substituting that with what? That's your U squared, right? Because that's the guy that's double the power of this one. So you're going to say that this is U squared minus 4 times x plus 7 to the 1/3 gets rewritten as what? That gets rewritten as U, and then there's minus 5 is equal to 0. So I'm using a different colored pen here to keep in mind that I'm not dealing with the original equation right now. I'm dealing with something that's analogous to that, but not exactly the same. So then what would you do? If you saw U squared minus 4U minus 5 equals 0, how would you try to solve that? Right. So how does it factor? Any takers, or do I need to do everything? What are the factors of 5 that subtract to 4? So it's going to be 5 and 1. So U and 5 and U and 1. What are those signs? So that you get a negative 4 when you add and a negative 5 when you multiply. Negative 5 and plus 1. And then from here, you use that zero factor theorem. So what is U? U equals positive 5, or U equals what? U equals negative 1. Now, please don't take this the wrong way, but I don't want U. I want to go back to my x. Okay? So this here was just, and this is really a horrible representation of life in general, where U is just a substitution, right? U are a substitution for the x. You want to go back to the original, right? And please do not take anything that I say as any kind of relationship advice where you say, hey babe, I need to go back to my ex. And they say, why? And you say, my math teacher told me. Bad idea. I don't need any more of those emails. So instead of U, I go back to what U is representing. He's a stand-in. Oh dear, this really is relationship. This is a stand-in for the x plus 7 to the 1/3 power. That is what is equal to 5. Right? So now I'm going back to the original black pen. What does it mean to be to the 1/3 power? How did we deal with that yesterday? Well, it's a rational power, and the way that we made sense of it yesterday is that the denominator is really our index. So it says to the 1/3 power, but this is really the cube root of x plus 7 that equals 5. And then, as you were saying, we are going to have to deal with that reciprocal power, but we're going to really use the power property. So what power would you use to undo a cube root? You were here yesterday. You're going to raise it to the 3rd power. when you're using a power property to undo this radical, the power has to match the index. So from here, that means that x plus 7 equals 5 to the third, which is everybody. I guess everybody is just one person. I've got a very small class today. That's 125. And then how do you finish getting x by itself? You subtract 7 on both sides. And x equals 118. I guess I should probably edit some of the things that I say, or else I'm going to get trolling comments where people say, wow, this guy's super sarcastic and rude. Oh, that's you? Thanks for that. Now I know who to block. All right, so going back to what you were saying, though, over here, if I rewrite this as x plus 7 to the 1/3, let's look at it in the way that we saw it yesterday, where I will raise both sides of this to the reciprocal power, which is 3 over 1, which is really just 3, right? And you see that's the same thing that I did over here the first time. So when I raise something to a power to its reciprocal power, I just get the base left over, x plus 7, and negative 1 to the third is what? Whenever you're ready. Negative 1, right? You're not multiplying times 3, you're doing negative 1 times negative 1 times negative 1. And you finish solving for x by taking the same step you did on the left. You subtract 7. So all told, x is equal to negative 8. This is kind of a weird question because there's nothing in the original problem that said we were going to have two solutions. Because the original problem is really made up of pieces that were radical. They had the rational power, so we didn't know exactly how many solutions we were going to have, as opposed to the last problem where we knew, since it was a polynomial equation, the degree told you the number of solutions. If you check these guys individually, one at a time, you'll see that they do work out in the original equation. Questions? If you have questions, you can leave them in the comments. I may or may not respond to them. Like and subscribe.